All right, the goal of today's lesson is to be able to add and subtract those rational expressions we've started talking about. The first example says, in order to produce a picture that is in focus, the distance between the camera lens and the film, which we call Q, must be controlled so that it satisfies a particular relationship. If the distance from the subject, that's kind of what you're taking the picture of, to the lens is P, and the focal length of the lens is F, then this formula that they show here can be used to determine the correct distance between the lens and the film. So in this problem, they tell us 1 over F is equal to 5, 6. So it looks like we can substitute that in place of that. 1 over P is equal to 1/4. That means we can substitute that for here. They want us to find what is 1 over Q. Well, if we put this into the formula, then we got 1 over Q equals 5, 6 minus 1/4. Okay, so if we're going to solve for 1 over Q now, we need to subtract fractions. If you think back to when you first learned to solve fractions, in order to do adding or subtracting with fractions, you need a common denominator. So this requires us to figure out what's the common denominator between 6 and 4. Well, the least common multiple of 6 and 4 is 12. So what we want to do is multiply the first one by 2 over 2 to get a common denominator of 12. And the second one we want to multiply by 3 because 3 makes 12. So that means you also got to multiply the top by 3. So an equivalent problem would be that 1 over Q equals 10/12 minus 3/12. Well, we know 10/12 minus 3/12 is the same as 7/12. So that would be what 1 over Q is equal to. So when you're doing adding and subtracting of fractions, you need to get a common denominator. All right, so we'll kind of remember that as we go here. So when you're finding least common multiples or LCMs of polynomials, so we're going to need to be able to find least common multiples to get common denominators. You want to find the least common multiple in factored form. So that contains each factor of the greatest number of times the factor appears. So just some quick examples. We just did this one of 6 and 4. The least common multiple would be 12 because 12 is the smallest number that both 6 and 4 go into, because you got like 6, 12, 18 and so on, and 4 you got 4, 8, 12, 16 and so on. The first number that appears twice is 12. That's the least common multiple. If you want to find the least common multiple of things that are polynomials, you want to factor them first. So this first one here does not factor. It's just going to be P minus 3. The second one does factor. Okay, so we want to factor that. So in factored form, that would be P and P. What multiplies the negative 27 and adds a 6? Plus 9 and negative 3. So what's the least common multiple going to be of that? Here the LCM, or least common multiple, would be P minus 3 because they both have 1. Okay, but then this one also has a P plus 9, so that would be the least common multiple, both of those together. Just some things that, again, when you're finding these, some steps, if you want some steps to follow, factor first, multiply each polynomial by the factors it's missing, and then use each factor the greatest number of times it appears when you're done. That would be your least common multiple. So let's do a few examples here. Number 2, what's the least common multiple of these 3 terms? Okay, so to find the least common multiple, let's start with the number. We got 12, 27, and 18. We could do it kind of like we did before and list out all the numbers so we see the one that appears as the least common multiple, but that might take a while, especially when we start getting with bigger numbers. So another way you can do that is to break the numbers down. What's their smaller factors? So we're going to factor 12, 27, and 18 and find some smaller numbers that go into that. Basically, we want to find like the prime numbers. So 12, one way we could break up 12 would be 3 and 4. Now 3 doesn't break up anymore, but 4 does. 4 breaks up into 2 and 2. None of these numbers now break down any farther. So 12 is the same as 2 times 2 times 3. Or another way of writing that would be 2 squared times 3, since we have two 2's. So that's the factorization of 12. Let's do the same thing now with 27. 27 is the same as, I don't know, 9 times 3. 3 doesn't go any farther, but 9 breaks down to 2 more 3's. So 27 is the same as 3 times 3 times 3, or 3 to the third power. So that's the factorization of that one. 18 is the same as 6 and 3. 6 we can break down farther into 2 and 3. And so another way of writing 18 would be 2 times 3, or 2 times 3 squared. So now if you want to find what's the least common multiple of these three numbers, we want to find out, look at the factors and find the greatest number of times it appears. So let's start with 2. What's the greatest number of 2's we see? Well, this one has 2 of them. The 27 didn't end up with any 2's as a factor of it. 18 ended up with 1. The greatest number is 2. So the least common multiple of this one for the numbers is going to be 2 squared, because that's the most number of 2's. Okay, now let's look at 3's. This one has 1. This one has 3. This one has 2. The most number was 3. So the least common multiple number-wise of this is going to be whatever 2 squared times 3 to the third power is. So what you can do then is go on your calculator and figure out, what does that give you? 2 squared times 3 to the third power is 108. So the least common multiple of this one is going to be, number-wise, is going to be 108. Now we want to go through and do the same thing with the variables here. What's the greatest number of times it appears in any one factor? So let's start with A here. How many A's do we got on the first one? 2. The second one has 1. The last one has 5. What's the greatest number? A to the 5th power is the greatest number. B's, we got 4, none in the second one, 2 in the last one. B to the 4th is the most. And then we're not done. There is some C's here. It looks like C to the third power is the most for C. So this would be the least common multiple of all of these. All right, let's try another one here. On number 3, we want to do the same thing. So why don't, on number 3, you guys pause it. See if you can come up with the least common multiple on this one. All right, let's see how you did. The number-wise here, if you're breaking up these numbers, 6 is the same as 2 times 3. 42 is the same as like 6 times 7, and then 6 we can break up in 2 and 3, so that's the same as 2 times 3 times 7. And 36, same as like 6 times 6, and both of these break up into 2 and 3. So this would be the same as 2 squared times 3 squared. So for the least common multiple, it's going to be the most number of 2's would be 2. The most number of 3's is also 2. And we got one other number here, a 7, in that second one that needs to get multiplied. So whatever that comes out to be, that's the number. As far as variables, the most m's we see is 3, the most n's is 5, and the most p's was 2. So the least common multiple, if you multiplied those numbers out, was 252 m to the third power, n to the 5th power, p squared. All right, so that's what it looks like if you're doing ones that don't need to necessarily be factored too much. And the numbers we kind of factored, but the variables were not ones that need to be factored. Now these ones do have some factoring involved. If you see pluses and minuses, your first step is to factor. So if we're going to find least common multiple here, we need to factor these first. So let's look at number 4. First thing I see in number 4 that we should look at for factoring is greatest common factor. Always check greatest common factor first. Is there something we can factor out of all 3 terms here? Yeah, a p. we can take a p out of all these. So if we take a p away, then it'd be p squared plus 5p plus 6 left over. Now you got to check, does this factor anymore? I believe so. That's a quadratic. The two binomials it factors to would be p plus 3 times p plus 2. So that's how that one factors. Now let's do the same thing on the next one. There is no greatest common factor on the second one, but this one does factor to p plus 3 times another p plus 3. All right, so that's the factored version of both of those. Now let's write out what the least common multiple would be. Well, the second one we just factored, the two factors were the same, so that's the same as p plus 3 squared, since we have two of them. So we want to write out what's the most we see of anything. Well, starting with that first one, there's a p. The second one didn't have one, so we do need to include it, though. The next one's p plus 3. The first one had 1, the next one has 2. We want to always do the most. So p plus 3 squared is going to be part of it. And then there's a p plus 2. The second one did not have a p plus 2, but you need to include the most number of them, which is 1. So this would be the least common multiple for that one. All right. Let's try another one of those. On number 5, this one has two things, and again, you see plus and minus, so it looks like we're going to have to do some more factoring. I always start with greatest common factor, and it looks like this first one does have a greatest common factor of k that we can factor out. So if we take that out, we got 2k squared minus 5k minus 12 left. We want to see, can we break that down any more? It's a quadratic one. It does look like it's going to factor here. So we want to write our two binomials. Now this one has 2k squared. So one of these is going to have to be a 2k. The other one's going to have to be a 1k. Now the other thing we know for this is that the other term should multiply to a negative 12 there. So what numbers are going to multiply to negative 12? We got some options. We got like 3 and 4. We got 6 and 2. It could be 12 and 1. Let's pick one and try. Let's try like minus 6 and plus 2. What would that be the answer? Well, if we multiply this out, that would be 4k. And this would be negative 6k. Is that added together equal negative 5? No, that equals negative 2. So it doesn't look like 6 and 2 work. Let's try another option here. Let's try 3 and 4 and see if that maybe gives us something better here. So let's try like minus 3 and plus 4. That also multiplies to negative 12. Let's see what happens when we multiply these together. This gives us 8k. This gives us negative 3k. Does that add to negative 5? No, it adds to positive 5. But I think we're on the right track with this combination. All we need to do now is change the signs. If we change the signs, they should add up to negative 5. So this one should be plus 3, and the second one should be minus 4. Now that's the correct factored form. So that's how that one factors. Let's do the same thing now on this second one. What's the second one factor to? Well, this one also has a k we can start by taking out. Okay, and what's left is a quadratic, so it looks like it factors more into two binomials. This one's a little bit easier because there's not a number in front of that k. Well, it multiplies to 16 and adds to negative 8. I believe this one we get 2 negative 4s are going to work. Okay, and another way of writing that would be k minus 4 squared, since we have two of them. So now what we want to write out is what is the least common multiple going to be for this one. So our LCM, or least common multiple, okay, would be a k, because they both have 1k on them. When we look at the next one here, they both had a k. This one has a 2k plus 3. The second one doesn't, but we need to include one. You always got to include the most of anything. And then the next one's k minus 4. This one has 1. This one has 2. We want to always include the most. So k minus 4 squared. That would be our least common multiple. Now, the reason we have you practice these least common multiples is when we go into these next problems where you have to find a common denominator, that is basically what you're doing when you find a common denominator, is finding the least common multiple. So now when we get into the adding and subtracting here, when you add and subtract rational expressions, it's just like fractions. To add or subtract, you must have common denominators. So you got to always go through and figure out what's the common denominator. Like if you have 2/3 plus 3/5, the common denominator, the least common multiple of 3 and 5 is 15. So here you'd have to multiply by 5 over 5. Here you'd have to multiply by 3 over 3. Now you have a common denominator of 15. You add the numerator. So you got 10 over 15 plus 9 over 15 would equal 19/15 as the answer. Denominator doesn't change. That stays the same when you're adding fractions. Same with the second one. The second one wants us to add what's a over c plus b over d. You got to get the common denominator. So common denominator here would be c times d. So this first one you would want to multiply by d over d. And the second one, c over c. And so you got a d over cd plus bc over cd. Now, this one, when you add it together, it's got a common denominator now of cd. The top, they're not like terms, though, so you just write it as ad plus bc on top. Okay, so variables, sometimes you might not be able to add the like terms together when you're done. All right, let's try some out. Number 6 wants us to add these two fractions together. So we need to find what the common denominator is going to be. So starting out with the numbers 15 and 18, what is the least common multiple between 15 and 18? Well, let's break it down and see. 15 is the same as 3 and 5. 18 is the same as like 2 and 9, and 9 we can break up into 3 and 3. So that's the same as 2 times 3 squared. Well, it looks like the least common multiple here would be 2. 2 3s, since that's the most, and also a 5. So if you multiply 2 times 3 squared times 5, that's the same as 2 times 9 times 5. That's the same as 2 and 5 multiplied together is 10 times 9 would be 90. So 90, it looks like the least common multiple here. So we want to figure out what should we multiply these to get to 90 would be one thing. So with that first one, to get to 90, if you take 90 divided by 15, I think we get 6. So we want to multiply both of these by 6 as one thing. And the second one, 18 times what is 90, I believe that's 5. So 5 and 5 is what we want to multiply by there. Okay, but we're not done. There's also some variables that we need to match up. What variable-wise, what are we going to have in our least common multiple? Well, it looks like 1x and 2y's we're going to need. So does the first denominator have an x? No. So we need to include x as part of this too. Does it have 2y's? Yep, it does have 2y's. So let's move on to the second one. Does it have an x? Yes. Does it have 2y's? No, it only has 1. So this second one also needs another y here to make it the same as the other one. So now we do our multiplying. On the first one, if we multiply these together, in the numerator, we got 42x squared now in the numerator. On bottom, it's going to equal 90xy squared. Plus, on the second one, if we multiply the numerators, we got 5y squared. And the bottom, we got 90xy squared. Now we can add these together because it's like terms. Now the top two terms, we can't write it as like 47x squared y. Don't do that because they're not like terms here. One variable's x, one's y. So we just have to write it as 42x squared plus 5y squared. But now we can combine these into a single fraction with a denominator of 90xy squared. So that would be this added together as one fraction. So if you want to make it into one fraction, you got to find the common denominator. All right, number 7. Same type of deal here. This one is subtraction, but the idea is the same. You got to get it into a common denominator. So on the first one, in the second one, we both have a number 9 and 7. The least common multiple there is going to be 63, or basically 9 times 7. So this first one's going to need to get multiplied by 7 on top and 7 on bottom. Also looks like that second one needs an A. Or I'm sorry, the first one needs an A. The second one has an A. The first one doesn't. And the second one also has 2 B's. So this is going to need an additional B2 to make it the same as the other one. All right, on our second fraction, AB squared, the variables are fine, but we need to multiply this one by 9 in order to make it the same as the other one. So now if we do our multiplying, on top here we got 56A squared B. On bottom we got 63AB squared. On the second one, 9 times 1 is 9. And on bottom we got 63AB squared. Our denominators are the same, so now we can combine this into one fraction with a common denominator. And these are not like terms in the numerator on top, so we just write it as 56A squared B minus 9. And that's the answer. That's one fraction. Okay. Why don't you pause it, try the number 8, see if you can do number 8 now on your own. All right, let's see how you did. If you did this one, it looks like that's the least common multiple of the denominators is going to be 8m squared n squared, so you need both denominators to have that. This one you got to multiply by 8 over m, 8m over 8m, and the first one needs 1n, so you should have multiplied by n over n. And if you did it right, the final answer on this one should come out to be n plus 16m over our common denominator here of 8m squared n squared. All right, number 9 is a subtraction one. Again, once you pause it, try number 9 out, see how you do, and see what you get. All right, let's see it. The least common multiple on this one should have been 15xy. So this one should have been multiplied by 3x over 3x. And the first one should have got multiplied by 5 over 5. And if you go through and do this one, you should have gotten 10 minus 9x squared over the common denominator of 15xy, if you did it right. Okay, so those ones aren't too bad. The last ones we're going to look at now, a little bit harder because some factoring is going to be involved. Once you start seeing plus and minus signs, now you got to include factoring. So on number 10, we see pluses and minuses. We got to factor this first. So let's go through and do all the factoring. The numerator on this first fraction, there's no factoring. The bottom there is we can factor out a greatest common factor of 4 there. Okay, on the second one, again, numerator doesn't look like there's any, but the denominator, we can factor out a greatest common factor of 2 there. All right, so now we got to figure out how do we make those denominators the same? What's the least common multiple going to be? Well, they both have a w minus 4, so that part's good, but the number that factored out is not the same. The first one has a 4, the second one has a 2. We want those the same. So the easiest way to make them the same, looks like this one we'd want to multiply by 2 over 2 to make them the same. Okay, then they'd both be 4 times w minus 4. So now let's do that multiplying. We got 4 plus, or we got this one over 4 times w minus 4. On the second one, if we times these together here, you're going to have 2 times w plus 4 on top. Because we got this 2 here, that's this 2 here. And then on bottom, 2 times 2, that's going to be 4 times w minus 4. All right, now we can combine these into one fraction. So let's combine them into one fraction. Now we got w plus 12 minus 2 times w plus 4 all over our common denominator. Okay, now this is not bad. We got it down to 1, but the last thing that you're going to need to do on these, especially if it's like an ACT question, is to simplify if possible. So now we got to look, does this simplify down at all? Mostly the place you want to look is the numerator. Does the numerator simplify into anything else? So on the numerator, looks like there is some simplifying we can do, especially we got a number here in front of a parentheses. We want to distribute. Now be careful at what you're distributing here. It's minus 2 times w plus 4. So you want to include that negative sign when you're distributing through. So you're almost distributing negative 2 here. So you're going to end up with w plus 12 minus 2w, and then negative 2 times 4 is going to be minus 8 over our common denominator here. Now, you could distribute back through in the denominator too. It's not worth it though. You actually want to leave it factored to see if anything else cancels later. So numerator, we can still combine together some like terms here. These are like terms. So w minus 2w would be negative 1w, or negative w. And 12 minus 8 is going to be 4. Okay, so now we want to see, does anything else simplify here? Now this one's kind of hard to see, but it actually does simplify a little bit more. Look at how these are very similar. You got a w and a 4 and a w and a 4, and there's a negative sign here. There's also a negative sign here. Now they don't look exactly the same, but they are close. What we could do to make these the same is on the top factor out a negative 1. If we take a negative 1 out, look what's left. So if we took a negative away from this term, you would end up with just w. On the second one, if we factored out a negative, this 4 then would become negative. Okay, notice if we just multiplied this negative 1 back through, you'd get the same thing. You'd get negative 1w, negative times a negative would be plus 4. Okay, so it's the same thing, it's just factored out. So let's see what this ends up being now. So if we did that to the top, on the bottom now we still have this 4 times w minus 4. If you have the same thing on top, same thing on bottom, and it's being multiplied, we can do like we did before. This now cancels out. So it looks like this answer, all that stuff we started with, simplifies it down to just negative 1/4. Okay, that's why we keep the bottom. That's why we don't distribute on the bottom, because sometimes it cancels all the way down like that. So with all that stuff we started with, you wouldn't think that all this would end up equaling just negative 1/4, but it does. So that's why you go through and do adding and subtracting with fractions. All right, let's try another one here. Number 11, this one's an adding one. Okay, but we know, same thing, adding, subtracting, we need common denominators. So start first and do any factoring. Numerator, that's just a number, that doesn't factor. The bottom of this one, though, is one of those difference of squares. This factors to x plus 2 times x minus 2. Plus, x doesn't factor, and x plus 2 also doesn't factor. Okay, but we need a common denominator. Looks like they both have an x plus 2, but the second fraction needs an x minus 2. So we'd multiply by x minus 2 over x minus 2 to the second one. So now we got 1 over this. Plus, on the second one now we got x times x minus 2 on the numerator. On the bottom we got x plus 2 times x minus 2. Now our denominators are the same. We should be able to add these up into one fraction. So we'd have 1 plus x times x minus 2 all over our common denominator on the bottom. So now you just got to look, does the top simplify? I think we can here. There's some distributing we could do. So that turns into x times x is going to be x squared. X times negative 2 is minus 2x. And we still have this plus 1 here too. So now, hey. Okay, and then over our denominator, so we got to see, does this factor anymore? Does the top factor? I think it does in this case. What multiplies to 1 and adds to negative 2? I think that factors to x minus 1 times another x minus 1, because negative 1 times negative 1 is positive 1, negative 1 plus negative 1 is negative 2. So then, look, does anything cancel out? Now, on the last one it did. Does anything cancel out here? Nope. So your answer would be this, or you could answer with that too, since nothing canceled. Either of those two would be good answers for this one. Or one other way, I guess you could write it too, since we got x minus 1 times x minus 1 on top, you could also write it as x minus 1 squared over x plus 2 times x minus 2. So depending on how the ACT has the multiple choice answers, one of those three would probably be the answer. All right, number 12, let's try another one here. This one, you see some pluses and minuses again. Looks like we're going to have to do some factoring. On the denominator here, it looks like it's a quadratic. So it's going to factor into two terms here. But this one has a 3 in front. It's one of those tougher ones. That means one of these is going to be a 3x, and one's going to be a single x. Okay, now we also know whatever these other two numbers are, they need to multiply to 5. So the only way to multiply to 5 is actually 5 and 1. We just got to figure out which order should we put the 5 and 1 in. Let's just try one. Let's try plus 1 plus 5. So would this work? If we multiply those, we get 15x. If we multiply these, we get 1x. 1 and 15 add up to 16. That's not what the middle term up here is. It's 8. So let's try switching them around since that didn't work. Okay, let's try. Let's try it with plus 5 here and plus 1 here. Now if you multiply those, you get 3x. If you multiply these other ones, you get 5x. Those do add up to 8x. So that's how you factor that one. All right, let's try the other one here. X minus 1 is on top. Nothing factors there on bottom. It looks like there's the greatest common factor there. The biggest number that divides into both 12 and 20 would be 4. So we got to factor a 4 out. So 12 divided by 4 is 3x is going to be left there. 20 divided by 4 is going to be 5. All right, so now let's find our least common multiple. What's the LCM going to be for the denominator? What's the thing everything needs? Well, a 4. Both of them are going to need a 4 because there's a 4 here. A 3x plus 5. Both of them already have that, so that's good. But there's also this x plus 1. So we need both denominators to be that. So what do we need to multiply? We got to find what's missing. The first one looks like it's just missing the 4. So we got to multiply by 4 over 4 on that one. The second one's missing the x plus 1. So we got to multiply by x plus 1 over x plus 1. All right, so on the first one now, you got 4 times x minus 1 on top. On bottom should be our common denominator. On the second one, we're going to have x minus 1 times x plus 1 all over our common denominator. Okay, now we want to combine these into 1. So if we combine them into 1, we'd have 4 times x minus 1 minus this. All right, so we've combined it into one fraction. That's one of our goals. Now our last thing, simplify to see if anything else cancels out. So there's some multiplying we're going to have to do here. We're going to have to distribute. Here we're going to have to multiply all this out. So that times that, that times that, that times that, that times that. If you want to use that little FOIL acronym to help you, you can do it first outside, inside, last. So let's see what we get. 4 times x is 4x. 4 times negative 1 is negative 4. On this second one here, we got to multiply all that stuff out. So x times x, x squared. X times 1 is 1x, or just x. Minus 1 times x is minus x. And negative 1 times positive 1 is negative 1. All over the bottom. Okay, so you want to now check, does anything else cancel here? Well, before we can do that, I put these things in parentheses here, and the reason I did that is all that stuff needs to get multiplied together, but then it also needs to get subtracted here. So we got to subtract everything in that second one. Okay, so we've done these before. If you want, you can go through and change this to a plus, and all these other ones then need to switch signs. Okay, so we need to basically subtract everything in that second one. So it ends up being 4x minus 4 plus negative x, or minus x squared, plus negative x, so minus x, plus x, plus 1. So is there any like terms we can put together yet there? Yeah, it looks like there is. One thing I noticed right away, if we got a minus x and a plus x, those equal 0. And I think these are some like terms we can put together. So if we do all that, we end up with negative x squared plus 4x, and then minus 3 all over this. Okay, so now you want to check, does that factor any more? It might. The top looks like a quadratic. It's kind of tough to tell, though, when there's a negative sign in front of the x squared. So if you have that, let's take a negative out and see what this looks like then. So all the signs on these would change. So does that top now factor any more? Is there anything that multiplies to 3 and adds to negative 4? I think there is. That one would factor to x and x. And what multiplies to 3 and adds to negative 4 would be minus 3 and minus 1. Okay, so we got it totally factored on top. Now you want to see, does anything else cancel there? Is anything the same on top as it is on bottom? It doesn't appear that there's any ones the same. These last two are pretty close, but the sign's different, so they don't. So since nothing else factors, that would be your answer there. Or you could leave that as your answer, would be fine since nothing factored. Or even this could be your answer. But you want to always check first, does it factor out? Because sometimes stuff cancels and then there would be a more simplified answer. All right, on number 13, why don't you pause the video, try this one out on your own, see how you can do on this one, and see what you come up with for an answer. All right, if you did it right here and factored it, you should have seen that the first one factors to a plus 5 times, or a plus 4 times a minus 5, which means that second one we need to multiply by a minus 5 to get a common denominator. And if you do that, you end up with this. And then if you combine them into one fraction, you should have gotten it here. Now, the last thing you got to check, does it simplify at all? So it looks like there's some distributing you have to do here. Distribute this to both. And hopefully you saw that it's a negative 2 you need to distribute. So it'd be minus 2a. Negative 2 times negative 5 would be plus 10. If you had minus 10, go back and change that. Last thing here now, is there any like terms? Yeah, these first two are like terms. Looks like that would be a negative a plus 10 over a plus 4 times a minus 5. Now nothing here on the top else is going to factor, so that looks like your solution right there. All right, try some of these out now on the practice sheet on your own.